For the second question, need to calculate the average angular velocity of knee flexion. Okay, so let's look at a joint motion here. Where does knee flexion happens? For knee, flexion means the angle is decreasing, right? So from this picture to this picture, the knee is actually doing flexion. So let's eyeball the motion. From this figure to this figure, what's the knee doing? The angle is increasing, so it should be extension, right? And also from this knee to this knee, the angle increases a little bit. If you already measure all the angle, you should be able to identify that. So from here to here, it's also knee extension. So that's why you have two answers to calculate the angular velocity of knee extension. So in this video, I'll cover the flexion velocity, and I'll leave question 3 to 5 for you to calculate the velocity for knee extension, hip flexion, and hip extension. And if you see there are like 2 or 3 phases doing flexion, just pick one you like. So you need one answer for question 4, one answer for question 5, and 2 answers for question 3. So if we eyeball the hip joint here to here, the angle is also increasing, right? And for hip, that means it's extension. Okay, so now we've identified all the motion of the joint. Let's see, how do we calculate angular velocity? It's pretty similar to linear velocity, but let's take a look at the formula again. On the last page, you'll see velocity. Angular velocity equals to change of the angle divided by time. So it's angular displacement divided by time. Okay, so we need angular displacement divided by time. And how much is the angular displacement of knee flexion? It's from here to here, right? So that's 1 for 1.3 minus 111.8. That's the displacement. And if you remember, we got a reference or a multiplier in linear movement. But actually, the angle is not affected by the size. Like if you zoom in or zoom out our lab manual, it doesn't affect your angle. Sounds amazing, right? So the angular displacement, you don't need to multiply a multiplier. So that's the displacement. How about the time? From here to here, how long does it take? First, we need to look at the frequency, right? So we know, okay, the same is 30 Hertz. So between 2 pictures, that's 1 over 30 seconds. How many frames are there between this one and this one? There are 75 frames, right? From 15 to 100. So 75. And we know each frame takes 1 over 30 seconds. So that's 75 over 30 seconds for the time. Okay, so that's how you get the angular velocity. And when you're working on question 3 to 5, remember it starts from picture 5. That's one of the trap. Okay,